Unit 1 Chemistry, Chapter 15, Part 1. Now we're moving on to look at some different types of reactions in water. Okay. We're looking at reactions of acids and bases. So it's first important to know what an acid or a base is. They are things that change the colour of some indicators. They're all corrosive. Some are highly corrosive, some are just a little bit corrosive, but they all do corrode. The weaker acids, if you taste them, will taste sour. Okay, so lemons and vinegar. Look, the stronger ones probably taste sour too, but they would also corrode your tongue, so let's not try it. They react with bases and they have a low pH, and we'll be learning exactly what pH means over the course of this. Bases, on the other hand, they are things that are quite often found in cleaning products. They're caustic, so they can degrade living tissue. They feel a bit slippery. They react with acids, of course, and they have a high pH. Now, there's a number of different reactions that we know always happen. So anytime you add an acid to a reactive metal, you get salt and hydrogen. If you add that acid to a metal hydroxide, you're going to get salt and water. Now remember here, when we're saying salt, what we mean is an ionically bonded substance. We don't always need sodium chloride. If our acid was hydrochloric acid, hydrogen chloride, and our metal hydroxide was sodium hydroxide, then you would get sodium chloride as your salt and water. But if the acid was sulfuric acid and the metal hydroxide was calcium hydroxide, then you'd get calcium sulfate as your salt. Okay? If you add an acid to a metal oxide, again, you get salt and water. The ratios when you balance your equation will be different now. If you add a metal carbonate to an acid, now we get salt and water, but also carbon dioxide. And the same product with a metal hydrogen carbonate. And then finally, if you take an acidic oxide and you add it to a base, again, you'll get salt and water. You need to remember these general types because then it will help you work out what's made in different reactions and therefore be able to write correct balanced equations. So, what is an acid? Well, the Bronsted-Lowery idea of an acid is that this is our acid and it is going to donate this little red blob. Now what this little red blob is representing is a hydrogen ion, or just a proton, because remember, hydrogen has one proton, one electron, gives away its electron, so we're just left with a proton. So if you have hydrochloric acid, this is hydrogen and chloride ions together, we are going to lose this hydrogen ion and it's going to be transferred to the water, which is our base. Okay, so this is our acid, this is our base, and we make from our acid, we make its conjugate base, which is chloride. Okay, they differ by just one H+. From the water, which is our base, we make this thing here, which is called the hydronium ion, H3O+. And again, they differ by just a base. So in each acid-base reaction, you've got two different conjugate pairs of acids and bases. Okay, so our basic definition is that an acid is a substance which donates a proton. A base is a substance that accepts a proton. And you can use hydrogen ion or proton, either is fine, interchangeable because it means the same thing.